Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problem number 10, which is in part 1 of our fundamentals of AP Calculus A, B, and BC. This number corresponds to number 44 of the 1969 AP Calculus multiple choice release test item. So let's take a look at the question. It reads, the fundamental period of the function defined by f of x equals 3 minus 2 cosine square pi x over 3 is. So when you're looking for the fundamental period, you want to consider the standard form of the equation of a trig function that was covered in pre-calculus. So f of x, let's say f of x is written as a cosine b times x minus h plus k. Now, if you have a trig function in this form, the period can simply be computed by evaluating the expression 2 pi over b. Okay, so what we're going to do is let's attempt to express this function in this format so we can extract b, and then 2 pi divided by that value b will be our period. Okay, so we have f of x, a is negative 2 cosine. We can factor out, we also have a square there, and then we're squaring what? We can take out pi over 3 times x minus 0, we can just leave it as x, plus 3, which is our k. Now, are we in the position to compute the period? The answer is no. Now, if you weren't paying attention to this format, what you would do is you will say, oh, the period is 2 pi divided by b, which is pi over 3. If you multiply the numerator by the reciprocal of the denominator, 3 over pi, you get 6, option E, which is a trap. Okay, this is an incorrect answer. Why is that incorrect? Well, the general form, or the standard form for a transformed trig function has no square in it. So we have to address this square first before we can determine the period, okay? So how do we convert this form to a format with no square that's consistent with the standard form? We have to make use of a trig identity, namely the double angle identity for cosine. So if you think back to trig in pre-calc, cosine of 2 theta has 3 different forms. The form that is applicable here is the form 2 cosine square theta minus 1. Now, if you closely examine the right side of this function we have here, we have a 2 cosine square and an angular argument, okay? Think about this as being theta. Now, if we can isolate 2 cosine squared theta, we can make a neat substitution here with a function that has no square. So let's isolate 2 cosine squared theta. So we're going to have to add 1 to both sides. So we have 2 cosine squared theta equals cosine 2 theta plus 1. Okay, and then, oh, there's a negative there, so we might as well just introduce the negative. So multiply this by negative, and then this entire equation by negative. So negative 2 cosine squared theta is going to be negative cosine 2 theta minus 1. So we can now make a substitution here. Now, if we call pi over 3x, if we call theta pi over 3x, we're going to be able to generate this portion of our sum on the right side of this function. So let's make this substitution. We're going to have negative 2 cosine square. Now, instead of theta, we're going to input pi over 3x. Okay, let's color code it so we can see what's going on here. So pi over 3x on the left side. Okay, notice this is a perfect match with that. Now, what happens on the right side? We have negative cosine 2. Instead of theta, we're going to input the value of theta, which is pi over 3x. Okay? Pi over 3x minus 1. So this is the value of negative 2 cosine squared pi over 3x without a square. Okay, this can be simplified further. We can just express this as 2 over 1 and then just multiply um, horizontally. That yields negative cosine 2 pi over 3 x minus 1. All right. Now, notice that this just represents this portion. We also have to add 3 in order to have the exact value of f of x. So let's go ahead and write down what f of x is. F of x is simply going to be this function right here, negative cosine 2 pi over 3 times x minus 1 plus 3. All right, so one more step to simplify, and then we'll be ready to compute our period. So f of x is equal to negative cosine 2 pi over 3 x plus 2. Okay, so if you think about the other format we had, let's rewrite it so we can know exactly what's going on here. F of x is equal to a cosine b and then x minus h. In this case, h is 0, okay, plus k. And then we said that the period is 2 pi over b. Now, can you see what b is in this function? B is 2 pi over 3, okay? So b is equal to 2 pi over 3. So that follows that our period is 2 pi divided by 2 pi over 3. Okay, so we just multiply the numerator by the reciprocal of the denominator, which is 3 over 2 pi. And then we divide, and your period is 3. Okay? So we can clearly see that the answer to this problem is option letter C.